If you are a freelancer or a working professional trying to do freelancing in your part time, or a student who wants to freelancing, then this is for you. Most freelancers spend 45 minutes writing a proposal and seeing the bids, whatever to write. So most of these proposals get ignored at last moment. So I built an AI agent that writes 3 tailored versions in 30 seconds and scores them so you know which one to send. In this video, I am going to show you exactly how I built it line by line and why it works when generic ChatGPT prompts don't. If you are a developer who freelances or a freelancer who wants to work smarter, the next 25 minutes will change how you think about bidding on Upwork forever. So as you are seeing all of this thing, this just happened within 30 seconds. So let me show you how. Let me be very honest with you. I was spending way too much time on Upwork proposals, not because I am a very bad writer, because the process is very broken. You open a job post, you read it, you think about how to position yourself, you write something, then you second guess the tone. Should I sound more technical or more warm in this? You revise it 3 times, 4 times, or many times maybe. Then you hit send and hear nothing back. So I have been also there. And I know a lot of you watching this have been there too, especially if you are a working professional doing freelancing on the side, squeezing it in between your day job. So I asked myself, like, what if I treated this like an engineering problem, because I am also a working professional. So what does a great proposal actually need to do? It needs to show the client you understood their problem specifically, not like very generically. It needs to prove you have done this kind of work before, and it needs to match their tone, what they are saying, because a formal fintech client and a scrappy startup founder want completely different vibes. And it needs to end with a real call to action, not looking forward to hearing from you, right? So that's not a prompt, that's a pipeline. And when I realized that, I stopped trying to write better prompts and started building an agent for that, which will do this work for me. This is part 1 of what I am calling the Freelancing AI Agent series. Today we are building the Upwork proposal agent. In future parts, we are going to go deeper, building agents that actually solve the kind of AI jobs that find on Upwork. Real clients work simulated in like everything here itself, but we started here because this is the tool I wish I had when I started. So this is for you. Before we touch any code, let me show you the architecture, because this is what separates a real production agent from like you are doing giving the chat GPT everything and it will tell you the steps what you need to do. So first is this in this Upwork agent, you can see the graph.py, which is this the LangGraph pipeline which we have built, and this is the nodes.py. This is every agent steps just lives here. After that, this prompts.py, it is the all LLM prompts for all the nodes, like it is versioned here only. After that, this is the state.py. It is keeping all the shared state across all the nodes. And this is the profile underscore matcher.py. This is the smart skill matching logic, like what you have the skill, it is according to that it will match the skills for you, and it will give you the jobs. And this is the tracking, and we have used MLflow for the experiment tracking, and it will be all the things will be logged here in the MLflow underscore logger.py. So after this we have here history.py, like history what it is doing, that it is taking all of this experiment tracking and keeping all the things in the SQLLite run history. So we are using your SQLLite DB for storing our history, like where we have done the bidding and where we have done the job requirement, all the proposal thing. And after that, if we will go here, this is the app.py, which is our main Streamlit UI file where we have built our Streamlit application. And after this, this is the main thing, like freelancer underscore profile.json. Here your main profile will be here, where you can set all of the skills or whatever you want to write, all of those things, and what is your pricing you want to make, and what is your location, like that. So mainly this is the agent's brain. So here is the like mental model I have given you. So think of this as a like factory line. You put in a job description at one end, and the agent runs through all the like 10 specialized steps, each one doing exactly one job, and out comes a ready to spend proposal at the other end. And the key thing you can see here is you can't find anything like write me a proposal like that. You will see in the later section of the video as well, because each step is very narrow, focused, and very composable in a way. So that's what makes this agent work in a better way. So let me show you this is the like graph.py, technically like what we have done. This is the brain, the LangGraph state graph. So it is containing like 10 nodes and 10 edges, but one direction. So let me tell you how we have done this. Before that, I'll just tell you according to a story like format. Like if you are going for a job, then you are scrapping the job, and after scrapping the job, it is just extracting the requirements, and after extracting the requirements, it is matching the profile, and after that it is going to detect the red flags like it is authenticate or not, and after that it will go to the recommend bid section and it will generate the proposal for you. If it is generating the proposal, then the score proposal it will give you, and after that it will analyze all the keywords like whatever is there according to your skill match, then generate a follow-up prompt also if anyone has not tell you yet. After that it will also provide you the general like interview question answer if there is anything on your according to the job description. So as you can see, this is the step one. This is scrap job here. So this is the scrapping the job. If you give it a URL, it fetches the page, strips all the noise, scripts, nav, any footer, and gives you clean text. If you just paste the description manually, it skips the straight to like step two, and the step two is the exact requirement. This is where the Claude API reads the job and extracts the structured data. So required skills, deliverables, client tone, budget hints, experience level, and pure JSON out. So this is giving all the things. And that's step 3. This is the match profile. So what is this doing? Match profile is your profile lives in a JSON file which I have showed you there. So the agent compares what the jobs needs to like what you have and calculates a match score for that, and after that detect the red flags. So this is most of the people like skip very often, and it's the one that saves you from the most of the pain. I'll tell you later on this in the later part of this video, which is like then we are coming to the steps 5, which is the most biggest like very hot topic of this whole of the conversation. There is the bid recommendation, proposal generation, a quality scoring, keyword analysis, follow-up message, and interview preparation. So all automated, all in one run, and this is built with LangGraph, which gives us proper state management, and every node reads from the same shared state and writes back to the same of it. So I have provided here also a detailed structure. I have provided here a detailed structural image where it is showing the what nodes and edges are working step by step. So for better understanding, you can check this out from my repository link provided below in the description. So there is no passing variables, no spaghetti code like that. This is purely LangGraph. So we'll see later section how these things are like working. Before I show you how the agent is working fully and how it is built, I want to show you why it's built this way as it is, because you could do this in a very naive way, just chain function calls and everything. So let me show you why I have to do like this. Thing test.py I've been giving here. Suppose I will be writing one function here, pipeline, but I'll just take job text, what is there in the description maybe, then job URL, and what is the tone I want, like that. After that, job underscore text equal to scrap, I'll just scrap the jobs, job underscore URL, or it can take from job description as well. After that, yeah, it's coming requirements equal to extract the requirements in the job text, and if it's matching the profile or not, then the profile match. And after that, if it is any red flags are also there, then detect the red flags from the requirements. And you want to do any bid recommendation as well, recommend the bid, requirements, profile match from there itself. So like this I can give it everything, whatever you want. So this will work for you actually. It will run also. But now tell me, how do you add a new step between detect red flags and recommend bid if you want to do anything? So you update the function signature of recommendation bid, you accept this flags output, then you update the call site, then you realize okay, generate proposal should also see the red flag so it can avoid certain phrasings. So now you update the generate proposal signature too, then score proposal needs context, so every addition is a change cascade again and again. So what about the error handling then? If exact requirement fails, the LLM returns malformed JSON. So do you want the whole pipeline to crash or skip ahead with defaults? No, right? So in plain Python, you are just writing this as a like try or except block at every steps. But what about the UI? The Streamlit app needs to show the score, the red flags, the bid all separately, right? And with plain function, you are returning a tuple that keeps growing and growing. So at 10 outputs, it becomes a dictionary anyway. This is exactly the problem LangGraph solves here. So instead of passing the outputs between the functions as arguments, every step reads from and writes to a single shared object. The state, any step can see anything any previous step produced. So adding a new step means adding one node and one edge. So no function signature change at any time, and you can add in between the function as well. And in that shared whatever string you write, so everything is stored in a state also. So let me first check the state.py here, and that shared object is defined right here in this state.py. So let me show you like what a typed dictionary actually is and why it's the right choice for this statement. Okay, so if we'll go here and check this, that from Python we are just importing this type dictionary, optional list, any like those kind of library here, and in the agent state we are just mentioning here everything, like what is the row, job text, job URL, tone style, every agent state is here only. After that, any pipeline outputs also will be stored here, and any new feature output, suppose I have added this later, like red flags, build recommendation, follow-up message, any interview question and answer, all these things are here, and these are very optional. You can either store it or not, it's up to you. So the first question will be like for you, why type dictionary and not a regular dictionary or a Pydantic model also we are not using. So a regular dictionary gives you like zero autocomplete, zero error checking, and if you type like state something proposal draft and typo and all, so Python doesn't care until the runtime. And in a pipeline that takes 30 seconds to run, discovering a typo that like at step 9, maybe it will like very painful, that it will be like it will get failed there itself. So Pydantic would work too, and it is adding the runtime validation, but it also adds overhead. Every node writes triggers a validation cycle for a stateless pipeline that runs once for request. So type dictionary is the right trade-off here. So that static check type, like type checking at write time, zero runtime cost at execution time. Then next is like why almost is like everything optional here I have done. So if you will look at the proposal draft, right, that means at the start of the pipeline it's nothing, and scrape job also doesn't touch it, extra requirement also doesn't touch it, only the generate proposal writes to it. So if the state were a Pydantic model with required fields, right, you would have to analyze every field upfront, and even the ones that have not been computed yet, those also. Type dictionary lets field like start missing and get fields like progressively as the pipeline runs. So if you look at now the section 3, right, the inputs at the top, so these are what the user provides through the UI, pipeline outputs in the middle. So these are what the agent computes, and power features below. So these are the bonus outputs that make this more than a basic proposal writer. And at the bottom, if you are seeing, this is the MLflow run ID, latency, seconds, error, tracking fields. So that have nothing to do with any proposals or anything, but everything to do with running this reliably like over time. So every single node in this pipeline has the same function signature. It takes the full state, it returns the full state. The input section never changes after the scrape job. So everything else gets written very progressively. So this is the contract like that. And now if you will go to back to the nodes.py, right, where we are mentioning all of our nodes here and setting up this like 4 critical pieces of the infrastructure. So like most of the tutorials what I have seen, they have skipped this and jumped straight to the fun part. Like I'll say don't skip this, it's what makes the difference between code that works on your machine once and code that works in production. So this pattern is actually called a lazy initialization, and it's important to understand why we do it this way instead of just writing like a client equal to anthropic function at the top of the file and that's it, it's done. No, like when Python imports this nodes.py, right, it executes every top level statement immediately. So if you write client equal to anthropic and then you will give your API key at the module level, right, that executes at the import time. And if the dot environment file has not been loaded yet, then that os.get environment what you have written, it will give you none. And I have actually faced this issue when I was doing. And your anthropic client is initialized with no API key, and it will just crash like not very immediately, but it crashes the first time when you make the API call. So deep inside a pipeline run with an unhelpful error message, and you can't really figure out what's happening. So with this lazy initialization, the client is only created the first time it's actually needed, at which point the dot environment has definitely been loaded by the app.py. And if the anthropic slide is none, it will check. It means we created exactly once and reuse it every subsequent call. So no need to like do it every time. Don't need to do it. So that's the singleton pattern we say actually. So one shared connection across the entire pipeline. So this is what we have been like doing here in this. Then after this, if you'll see, notice that that get load dot environment is called inside the getter with override equal to true. That's defensive program actually what we have used here. Even if something else loaded environment variables earlier, we reload our specific dot environment file and override whatever was there. So for local development where you might have conflicting environment variables, this prevents like hours of debugging there. And after this, when these are the loading profile, and this is Groq also we have used it, I'll tell you in the later of the video. So now coming to this part is parsing those JSON. So this line whatever you are seeing in the function, right, is the most important piece of this defensive code in the entire project. So let me explain the problem it solves. You ask Claude to return JSON, right? And Claude is very good at following instructions, but it is not perfect. Sometimes it returns like, okay, JSON required skills, Python, LangChain, this, and see, it's gone. The JSON is wrapped in a suppose markdown code fences, something like backticks and the word JSON like that. It is not the perfect JSON file. So if you call this JSON.loads on that row string, right, you get a JSON decode error also, which I also like got it. This the triple backtick is not also a valid JSON. Sometimes you are also getting that, and sometimes Claude add a like sentence before the JSON. Sometimes it adds a sentence after it also. So sometimes, especially on complex prompts, it wraps the JSON in a single sentence, like the extractor requirements are this, and with one regular expression like that. So it makes the dot character match new lines. So the regular expression captures the JSON objects that span multiple lines, which is every real JSON object we are dealing with. So the regular expression finds out the final JSON object or array in whatever text the LLM return, regardless of what's wrapped around it. If JSON.load still fails, which can happen also, if Claude hallucinated a field, we return the fallback dictionary instead of crashing. And the fallback is defined at the call side. So each node provides its own sensible default. The pipeline never like really stops because of a JSON parse failure for sure. So this is not a edge case. I would estimate maybe 3 to 5% of LLM responses have some kind of formatting deviation. So without this function, that's 1 in 20 runs crashing. Otherwise, mostly it will not crash. And after this, this is the function where we are wrapping up this Claude and Groq. Both of are here. So as you can see here, these are two wrapper functions. So one for Claude and one for Groq also. Like I'm using both of them. So notice they have different signatures actually. Claude doesn't expose the temperature, but Groq does it. So this is like a very intentional way of doing it, because Claude is used exclusively for structured tasks like extraction, scoring, analysis, and for these tasks you do not want any temperature variation. Every call to Claude is like very deterministic, and same prompt should produce consistent JSON structure. Adding the temperature, I think, would introduce randomness into your data extraction, which is the last thing you want, I guess so. So Groq is used for very creative generation, writing the proposals, writing the follow-up. For this you absolutely want the temperature, like you want some creativity, right? Because temperature, suppose 0.7 if you are giving, it will give you natural slightly varied output that doesn't sound very robotic. And the variant proposals use 0.75, slightly more variation, because they need to feel genuinely different from each other, not just like synonyms shuffled around here and there. And the dot strip at the end of both the function, if you will see it, is not just very cosmetic. Some LLMs add a leading new line before their response content. So if you pass that into this parse JSON, right, so the regular expression still works, but if you are using the text directly into a Streamlit text area, so a new leading line is a like it will be UI work. So you have to strip all of those things, everything. So the scraper node, whatever you are seeing after this, right, this is mainly for the function of scraping the jobs we have written here. So let me walk through every decision in this function, because each one exists for a specific reason. The user agent header, what you are seeing here, is without this your request arrives at the server. identifying itself as Python's request library. So many websites, including Upwork, check the user agent header and return a like 403 forbidden or a like survey bot detection challenge page as well. So instead of the actual content, by sending a real Chrome user agent string, will look like a regular browser request. This is not like hacking, it's obviously it's http like we are using here. The server choose to get on user agent, which is not a very meaningful like security measure, but timeout we have given here something equal to 15 maybe. So if the server is slow or unreachable without a timeout request, it will just get back indefinitely. So its Streamlit UI will spin forever and your user will think it crashed and they will hard refresh, um, firing the whole pipeline again. So 15 seconds is very generous according to me. So if a page has not responded in 15 then 15 seconds it's not going to respond, and it will raise a status that this returns suppose http error codes like 404 403 500 like that into something as a python exception. And without this, a 403 response silently returns a page full of like access denied html, which then gets fed into like your llm as the job description, and your llm try its very best to extract the requirements from an error page. So I have seen this produce surprisingly confident JSON with very required skills like that, and authentication will bypass after that and raise for status answer that we only proceed with a real 200 response. And the beautiful soup tag removal, right? Let me show you what a raw job page actually looks like without this step. This is, let's see how the real job page actually looks like without this step. So I have go imported here request and beautiful so 4, and here on the terminal I have a little program. I'm just giving it here to see the real job page html, and this is for a url like news.ycombinator.com. So let's see this. So you are seeing this, right? That's all like javascript bundle code, css rule, navigation html, footer links, cookie consent text, analytics script. If you send all of this to your llm along with the actual job description, right, you will be burning the tokens on a completely irrelevant content and diluting the signal. So the llm might even pick up on a like menu item text like find work or post a job and decide those are the skills. So the 4 tags we remove, script, style, nav, footer, header, account for probably 60 to 70% of the noise in a typical job page. So after decomposing them in the get text, on what remains is almost entirely content text, and when you are joining them all of them together there with the separator, there still leaves multiple consecutive spaces, new lines between the tags, and Unicode white space character. So you have to just remove them each of them one by one, and this matters actually because when you are doing this and the LLM sees the tokens, not the characters. So a string with 20 redundant like new lines wastes very context window, and when the length of the text will be greater than 50, then you can check like after stripping all that HTML noise, if the remaining text is under 50 characters, then the script technically succeeded, but it returned nothing useful. Probably a bot detection page that said please enable javascript, something like that, or please verify you are a human. So we fall through to the manually pasted text rather than feeding the garbage to the pipeline, which is like we don't want it. So the extract prompt template adds roughly 300 characters of instruction text. So Claude Sonnet's context window is large enough that 8000 characters of job text is fine, but we are not the only call in this pipeline, right? If we let the job text grow unbounded, the entire pipeline could cost significantly more per run with zero improvement in output quality. So job improvement in output quality, like job description are rarely more than 2000 or to 8000 characters is like already very generous, and we don't want like more than that. So the entire try or accept around this http call, right, you can see like notice this except catches exception and the broadest possible catch. So that's how the scrape jobs will work, and if it is failing to scrape any url, then it will just give this and this try and accept block here what we have given. So that's why we should not cross the entire proposal line because one http request failed, right? So it will just cache in that accept block, and this is the now extract requirements. So if we'll go in the nodes.py, we have given here, and another one we will open this prom.py as well. I'll tell you why. So if we'll go here, where is nodes.py? Yeah, here. Okay. Okay, so if you see here, then let's start with a question like, why does this node exist at all? Like, why not just pass the raw job text directly to the proposal generator? That's it, right? We are done with the task. But because it's proposal generator that reads the raw text, produces generic proposals. It has to guess what matters and what doesn't, and it doesn't know if the client cares more about the timeline or the budget. So whether this is a 2-week job or a 6-month engagement, whether the client wrote in a technical or casual tone, it doesn't know anything. So this extraction step converts this unstructured text into the structured data that every downstream node can use with precision. The proposal generator knows exactly who is skills to maintain and who is skills to not. So the red flag detector also has the budget hint to compare against the complexity. And the bid recommender has the experience level requirement. And extraction is only the foundation to do all of these things. Now look at this extraction notice. If you will see here, we have given here 6,000, not 8,000. So we already stored 8,000 in state from the scrapper, but here we only set 6,000 to the cloud. So the extraction prompt itself adds about 400 characters of instruction text. The total input stays well under 10k tokens, where we have reliable, fast, cheap responses. So the last 2,000 characters of most job posts are legal boilerplate, and about our company text that acts like zero signal for skill extraction. So now if you look at this prompts.py here, these are the v1 and v2 if you are seeing here. Okay, if you are seeing here, this is extract from v1, and you are an expert in analyzing Upwork job posting. Extract the key information from the job description below and return only valid JSON with additional no explanation, like that. So it returns only this exact JSON structure with no markdown, no code defense, and no explanation, nothing like that. It is like a very simpler version of your prompt. But if you want to go more deeper, this is the v2 prompt, and here it is like, analyze this Upwork job posting with depth, return only the valid JSON, no markdown or explanation. So if you are seeing here, both of these things, 3 things to notice about how these prompts are very engineered. Okay, so return only appears actually 4 times in v1. If you will see here, return only, here it is returning only, no markdown, no code fences, no explanation, like that. Okay, but that's not an accident. So LLMs are trained to be helpful, which means they naturally want to add context, explanation, preamble. Here is the extractization followed by the JSON, followed by I hope this helps. So that's a typical helpful LLM response, but it breaks the JSON.loads. So we say only once at the start, once in the format instruction, and once no markdown, and once no code fences, because each repetition targets a different type of formatting mistake Claude is prone to. So the double curly braces, whatever you are seeing here, right, what we are giving here, so this is the Python string formatting sentence. So when you call the dot format, anything like that for job text, between that, so on this string, Python processes every curly braces, whatever is there, is a format placeholder. So if your JSON schema has something in that, like dictionary, like key value pair, Python sees key as a format placeholder and raises a key error. So double braces are the Python's escape for a literal curly brace in a format string. If you have if you know Python, you can know this. So this is a production bug that fails silently in testing, and if you never actually call this dot format function. And here v2 adds 4 new fields actually. One is this urgency signals and decision criteria, pain points, red flags. So these are not the for the proposal directly. They feed into the red flag detector and the scoring node. So urgency signals tells you if the client is under pressure, that changes your bid strategy. And pain point tells you the core problem the client is actually trying to solve here. And the proposal should address the pain point, not just list the matching skills. Decision criteria is what the client is optimizing for, maybe price or speed or specific technology expertise. So your first paragraph should speak directly to whatever they listed. Now look at how the person is selected in the node itself. Whereas that, so if you'll see here in the prompt versions, so v1 equal to extract prompt v1, and the proposal has been given here, and same like v2. So this lookup pattern, like dot get version, whatever it is getting the version from there. So means if someone passes a version that doesn't exist, we default to v1, not an error, not any crash also will happen. And the user picks v1 or v2 in the UI. The state carries the choice all the way through to both the extract node and the proposal node. So one parameter controls both. If you'll see here it is v1 or v2, we can choose from here. It is according to that. If you added v3 tomorrow, you would add one entry to this dictionary and one new constant in prompts.py as well, and after that nothing else will change. Now let's go to the profile matching, which is in our nodes.py. So this is our function for this profile matching. As you know, this is in nodes.py, it's literally 2 lines. It calls the match skills function from this file, and all the work happens in that file actually, which is this profile matcher.py. And let me show you what it actually does, because this is not an LLM call, this is like very deterministic code here. So you are seeing this function, right, match underscore skills here. So first everything it is getting lowercase here and stripped. This is very crucial because someone is writing in small letter or big letter, something like that. And the LLM might extract the Python with a capital P. So your profile might list Python like without lowercasing Python in like profile skills returns false. So a false negative that tells the proposal generator you don't know Python. Now look at the actual matching logic. If you are giving here that match required equal to, so this is a substring match actually in both the direction, and both direction is the key inside. And the skill in profile skills here, so it handles when the job asks for LangChain and your profile list LangChain integration. The job skill is contained inside your profile skill string. So the profile skill in skill handles the reverse. The job asks for the LangChain RAG pipeline and your profile list LangChain. So your profile skill is contained inside the job requirement. So why not the exact match? Because skill naming is not standardized. Everyone can write anything. A job might say Groq API, but your profile says Groq, and a job says suppose AWS Lambda and your profile says AWS. So exact match would miss both of these things. A fuzzy library like fuzzy Uzi would work too, but adds a dependency and introduces false positives. So Java fuzzy matches you, if you know that JavaScript at a high enough score to cause problems. Substring matching is very domain centric. Now, if you look at this project relevance scoring, right, this is a custom scoring algorithm. Show you. Are seeing here this for project in project.get the top projects. Here if you are seeing here, first we are doing the score equal to 0, and this is the scoring function that determines which of your past projects gets mentioned in your proposal. So the weights are very intentional. Your text stack match scores 2 because it's the strongest signal, and you use the exact tool they need. And project type match scores equal to something 3 because it signals context familiarity, and you have done this category of work before. So you can mark that score as 3. And if you have done this category of work before and deliverable keyword match scores, then it will be 1 because it's the weakest signal. As you can say, nobody will look into that. And after that, a word match is like suggestive but very definitive as well. And after this, you will see the length of the word is greater than 3 filter on deliverables is a stop word guard. So we don't want to score a point because both the job description and your project title contain the word like the or end or API like that. So projects are sorted by score descending, and the top 3 go into the proposal. This means the proposal always references the most relevant work, not just your most recent or most impressive work, but the most contextually relevant to this specific job only it will give you. And in the UI you see this expressed as a percentage, like something 60% match, 70%, 87% match. So this is coming directly from this formula. And after getting all of these things, you can do this match underscore percentage. So it will just required skill match divided by the total required skills, and it will notice the if required skills as equal to 0 guard. If the LLM extracted 0 required skills, we don't divide by 0. So this is for the proposal generation. And if we'll go back to the nodes.py here again. So this is the generate proposal direction. So proposal generation is happening with like 2 LLMs here, but one architecture decision. So this is like the longest node. So let me break it into like 3 parts. One is like context assembly, primary generation, and variant generation, like that. So as you can see, this is the function generate underscore proposal. This first block is purely data assembly, no LLM calls yet. So we are pulling from 4 different places in the state: the freelancer profile, the extracted requirements, the matched skills, and the relevant projects. The scoring algorithms identified. So you can notice that each instance is being used here. So the each instance, if you will notice this is the matched and taking the dictionary as the parameter, and after before accessing the .get method. So that's a very defensive check. So matched skills in the state is typed as optional dictionary, which means that it could be none if match profile was skipped somehow, so that it will not crash as well. And calling this .get method on none raises an attribute error as well, so that would crash the entire pipeline at this state. So the ease instant check returns an empty list instead. After that, this the project underscore text. If you are seeing this is formatting is very important. So we are not dumping a like very raw dictionary into the format. We're formatting it as a readable bullet text like title, outcome, text tag on online. So this matters because LLM process prompts more reliably and the context are presented in a natural hierarchical format rather than raw JSON. And I have tested both of them. Like raw JSON in the prompt produces proposals that sound like they're reciting the bullet points. Formatted prose context produces like proposals that reference projects very naturally. Now comes the second part, the two LLM decision. So as you can see, this is the base keywords. In the primary prompt we have mentioned here all of these things. So this calls the Groq API actually, not Claude API. So let me explain why this is like I have made this decision, not a cost cutting measure for sure. Claude and Groq are optimized for both very different things. So Claude is exceptional at structured reasoning. Give it a very complex JSON schema and ask it to fill it reliably. It's the best tool for that job, no doubt. But for open-ended creative text generation, writing a persuasive like paragraph, varying its tone, sounding human, so Grok is running this Llama 3.370B, right, is genuinely comparable in output quality and dramatically faster as well. So the pipeline makes 10 LLM calls total per run, 3 calls to Grok for the 3 proposals and 1 call to Grok for the follow-up and 6 calls to Claude for extraction, matching context, red flags, bids, scoring keywords and interview preparation. So the Grok calls are the ones where latency is most user visible. The user is watching a spinner waiting for the proposals like that. And Grok returns in 2 to 3 seconds itself. Claude takes 8 to 12 for the same creative task. So that's the difference between what feels very like instant and or did it very like freeze there itself. And the 14 variables in this keywords arguments you are seeing are every piece of context the proposal needs, like who you are, what you have done, what the job needs, which skills match, what tone to use, how long to write, all of these things. So the entire intelligence of the proceeding 5 nodes is compressed into this one prompt call. And next come is the variant generation. Like depending on your tone, it will generate the prompt for you for the proposal. So this is the variant tones if you are seeing here. So the least comprehension T for T in confident, collaborative, technical, concise, all of this filters out whichever tone you selected as primary. Then takes the first two remaining ones. If you choose confident, variants are collaborative and technical. If you choose technical, variants are confident and collaborative, like that. So you always get exactly 3 proposals there, so never duplicates, or you can choose from any 3 prompts there. And after C, we are taking this V keywords for VT invariant tones. Why we have taken this here? Like this unpacks the entire base keyword arguments dictionary and overrides just tone style. So everything else, your profile, the requirement, the match project stays identical. The only thing that changes between the 3 proposals is the tone instruction. This is the like very correct way to generate any variant, some facts, different voice. So you can do this everywhere. And the temperature is 0.75 we are taking here. Variance versus 0.70 on primary and 0.05 higher. That small increase in randomness means the LLM makes slightly different word choices, slightly different structural decision. Without it, you would sometimes get variants that are essentially the same proposal with a few synonyms swapped only. So after this is the quality scoring, like why the Claude creates its own output, that is scoring the proposal here. So this is the function for that also we have written. So here 2 engineering decisions have worth explaining, I'll say. So why a nested function score 1 instead of a top level function we have used here? Because it closes our job requirements. A string assembled from the current state at the top of the score proposal, a top level function would need job requirements as a parameter, which means the caller has to pass it 3 times once per variant. The nested function captures it from its enclosing scope, and the caller just passes the proposal text. This is a like very readability and encapsulation process. And and the max, if you are seeing here, we are just doing the score here, and max 0, minimum 100. This pattern, the LLM is asked to return a score between 0 and 100. So usually it does, but occasionally it returns 103 or -5 or 100.0 float, like anything like that. So the chain handles all of these things also, like coming into this integration. If you are seeing here, I'm giving here, it should give me whole things. Okay, the chain handles, after handling all these things, converts the strings and float to integer if it has anything like that. So the outer try or except catches the case where data.getScore returns something like integer can't convert, like the string high and the defaults to 50 rather than crashing, those things. So the fallback score of 50 is meaningful, it's the midpoint. If scoring fails, the proposal is not penalized with a 0 and it is not falsely elevated as well with a high score. So 50 signals, we couldn't evaluate this one without hiding it from the user, like that. So these are the main important part. Next are this like generate follow-up, like if anyone has not done anything, so we are just writing a follow-up question within the 400 characters here, that if we need anything, and for that also we are using the Groq here. And this is the generate interview question answer, where according to your required skills and what is the key deliverables, and after the project type and the industry, it will just tell like what are the interview questions you should prepare for yourself. And this is coming from the Claude, we are using it here. So this is the 1500, and it will also take your job requirement and the profile summary from this get profile summary, and it is taking the prompt for this interview question prompt format, which is like coming from this prompts.py itself. So if we'll go here, we'll get the prompt like, okay, this is the interview question and prompt. So based on this Upwork job description, you can take this and return only the value JSON, no markdown, no code fences, and it will give the question answer pairs by calling to the Claude. So that's it for the nodes.py here. So next part is like MLflow tracking, which we are doing by the two storage systems. One is like MLflow logger.py and another is this history.py. So these are the two Python function. The tracking layer is actually two files, so most people won't build this. I want to convince you that it's worth the lines, like whatever I have written, this 75 or 150 lines, like mix of both, whatever I have written. So I'll just tell you what it's doing. As you are seeing, this is the db underscore path. It is taking something in the SQLLite and keeping that there. So the MLflow, as you all know, it is used for experiment tracking, the same tool ML engineers use to track model training runs. And here we are treating each proposal generation as an experiment run. So the distinction between log parameters, right, and the log metrics, it is like very important here. Because the parameters are things you configured with the prompt version, which models you used, project type, so that don't change during a run. Metrics are things that you measure, the quality score, the latency, the word count, the keyword density, like that. So they have numeric values that MLflow can plot over time. And after 50 runs, if you will open the MLflow UI, which is just MLflow UI like backend store URL, and you will compare that with the SQLLite, and it will like say V2 prompt score higher than V1 on average. If you will ask that, do technical tone proposals score better for data engineering jobs or AI engineer jobs? Does latency correlate with quality score? So you are kind of building a data set about your own proposal quality, and the backend is SQLLite, not a like remote MLflow server here. So that SQLLite prefix tells that MLflow to write to a local .db file here. This is here we are using this SQLLite 3 here, and we are getting the connection here. And after initializing with all of this, then I have created one proposals table here. It is storing all of these things, and whatever after like running the pipeline we are getting, it is just saving all of these things, and it is inserting those things here, like created a job snippet, project type, tone, and the bid recommendation, and what is the MLflow run ID which ran there itself. So there is no cloud cost or no Docker for this MLflow run, whatever we are doing there. So the UI will still work, and the charts also will work, everything will still work. So this is the right choice for a solo tool if you are doing something like tracking. And so if MLflow already stores everything, you will ask also, why does like history we are just doing here, and why it is existing here. So MLflow is an experiment tracker. It's optimized for comparing the runs, plotting metrics, and storing artifacts, but it's not optimized for show me all the proposals I wrote this week, or let me reopen the third one and edit it, something like that, because you must have wanted to see also, right, that what you have given there, what you wanted to see, and how many proposals you wrote. So for that, that's a like UI concern as well. For that, you want a simple queryable table, right, where it will store all of these things. And here it is a very SQLLite lightweight wrapper with 4 operations. Either you can save the run, load the history, and get run, or delete the run process. The Streamlit sidebar history tab calls this load history to show a list of like all the past runs if you want to see, and when you click one, it gets the run ID to load the full state for that run back into the UI. And if you'll notice, the extracted requirements, match skills, red flags, and those things are stored in the text columns as well, what I was showing you there. So they are just JSON serialized with JSON.dumps function, as you know already. And SQLLite doesn't have a JSON column type, but text works very fine with it. When you load a run, right, the Streamlit app calls that JSON.loads function on those columns to deserialize them back into the Python dictionary. So the MLflow run ID column is also the link between these two systems, what I was showing you there. So MLflow UI and the Streamlit application here. So every row in the history DB stores the MLflow run ID. So if you want the detailed artifact view, so you can look it up in MLflow as well. And they're complementary, like history for very quick access if you want to see anything, and MLflow is for deep analysis if you want to see anything. So that's it for all of the agent work, whatever we have done. And profile matcher.py, as you have already known. I think graph.py also we have already completed what it's doing. And these are the DB where it's getting stored here, and this is something I have tested. And for this you have to give your Anthropic API key and Groq API key in this .env example there. And this is the app.py here, mostly like Streamlit application, like what it is doing, it is taking all of the agents whatever we have done here and loading the profile, saving the profile. For the red flags, this is something like all the agents are getting combined here, and after this it will just cut the entire question and answer from here. And this is your profile, like what you need to write. So I have done this from my profile, and you can change it inside the UI also itself. Like just give, my name is Sweta Mahapatra, and this is the headline that I'm a senior AML engineer, LLM integration specialist. Then you should just give your bio, like what are the things, and suppose the location is Austin, Texas. And after this, what is your availability, you can write hourly rate and currency USD. And what are your skills, you can write all of these things like LangChain, LangGraph, whatever profession you are working, you can give all of those skills here. And what are the top projects also you have worked, those things also either you can give there as in just an example there, so that it can know that what you have worked on, like that. And after this, this is the requirement.txt, for that we need to need these libraries, all of these things to work all of these things. That's it. So now let's get into the demo, and we'll see like how the UI is working. Okay, this web page was reloaded because okay, my server is stuck. Let me just restart the server. Just give me a moment. Let me just start the server here for me. Environment, it's on 7860 port. Okay, welcome to Streamlit. If you like to receive onboarding, okay. I'll just give my full email here. agentic.lab@gmail.com. It's coming up. So it is coming up. Let's see, this is the real working job posting, and here it is running on the Streamlit app. So this is the main money section, no parts, real time, and it's very authentic. You can use it for any kind of profession if you are working. And let me show you how this is running for real. So let me go to Upwork and find a real job posting, and this is what I have tried for one of the job. So this is written like AI expert needed to help integrate AI into better flow. So I'll just take this whole summary job description from here. Oops. It's coming up. Now I'll just take all of these things and I will control C and paste here itself, or if I want, I'll take the URL one later. And this is like my profile, Sweta Mahapatra. And if we want to like quick edit your top skills, something like LangChain I don't want, or something like Groq API, I can remove all of these things if I want. And what is the hourly rate, I have set 95, and I'll just save and use my profile for this. And after this, I want more to be on technical part, so this is the technical, and this is the prompt version V1 and V2. I want to click on V2 because it is more in-depth. And this is the generate the proposal, so let's wait for some time and it will give us the result. And these are the profile editor. If I want to edit the profile also here, like I can edit. And these are the history which I have ran before for testing this out, so you can check those things. These are all stored in the DB itself. And okay, let's wait. This is running, and this is also showing that this will take for 30 to 60 seconds from here. So right now the LangGraph pipeline is firing in sequence, grabbing the jobs, Claude extracting the requirements, profile matcher comparing the skills, red flag detector analyzing for warning signs, build recommendation engine, looking at the budget signals, then Groq writing the 3 proposals, all of this happenings inside that, and Groq writing the 3 proposals. After that, Claude scoring each one, that what is your score and what is the keyword analysis, all of these things. Then after that it will also show you the follow-up message and whatever the interview preparation you need to do to get this job. So all of this sequential automated in about 30 to 60 seconds you will get it. Okay, let's see, this has come now, and this is the first tab. As you are seeing, this is the proposal variants, so 3 different proposals. So I have selected the technical one. So this is the technical one, that by reducing evaluation time from 2 weeks to 4 hours as seen in my past LLM evaluation framework project, I understand the significance of an efficient AI center. So it is fully technical, and the other one should be the variant that is the confident, and the other one is collaborative. So these are the 2 variants here. This is written in like that. So these are the 3 variants here, and these are the requirements skill which it got from there, from the job scraping. And these are the requirements like OpenAI API, Claude API, Gemini API, AI agents. Those things should be there. And the nice to have skills is React Native, Node.js, AI copilots, and assistants design. And project type is very long term, and budget here is $30 to $60 per hour, 30 plus hours per week for 6 plus months. And what is the key deliverables also it is showing, and they want the experience level as expert. And what is the industry? This is business management software for freelancer and small businesses they want. And what is the urgency signals, if it is urgent or not, because applications without app knowledge will be rejected, it is saying. And the specific gatekeeper questions required at the start of the proposal itself, it is telling you. And the decision criteria, what it is giving, demonstrated knowledge of their existing app, understanding of small business workflow. So you need to have the knowledge of the small business workflow, how you can make it. And the portfolio of successfully launched AI projects, strategic thinking about AI opportunities. And 10 points is like need to enhance existing business management apps with AI, identifying which AI features would provide highest impact for target users. And what is the red flag? It is also giving that strict gatekeeper requirement may filter many qualified candidates. Like it is very strict, so you need to learn all of these things, and requires unpaid competitive analysis work in proposal. So you have to give something there itself in the proposal. You have not even started the work, but you need to give there. And the broad scope with potentially undefined success metrics. So these are all of the things in the requirements. Now it's telling if my skill is matching or not. So match score is only 20%. Relevant past projects is like it is giving those things, but unmatched required skill is like OpenAI APIs, Claude APIs, Gemini APIs, rack system, AI powered SaaS product, because I have not worked mostly in mobile application, in AI integration, AI architecture designing. So those things I have not mentioned there. That's why it's telling that it is 20%, but these are the my cup, like I know all these things. And what is the score? It is giving like, okay, this is 68 by 100, which is Claude is evaluating that the proposal asks relevant discovery question about workflow and 10 points. So how it is doing, it is telling that also. And what are the red flags also, it is telling this is overall very high red flag, like we should not take this maybe, because the client behavior and all, it is telling all of this, like extensive unpaid specification work required here. So I don't think we should like bid on this actually. And if you are bidding, it is telling that you need to do, like even if mine is like 95 I have given, but we have to give it within 60 to $70 within that only. Otherwise we don't need to do. And what are the keywords in the presentation? It is getting like AI agents, workflow automation, prompt engineering, Claude APIs, like that. But we have the missing of better flow reviewed, better flow, OpenAI APIs, AI opportunities, AI futures. So it is giving you a suggestion that must begin with the better flow review as required, because we have not done this. So it will tell you also before going to the job that you need to do this. And what is the follow-up? This is something like very within 400 characters. It is asking that if it has seen or not, and it will be in different forms. And after this, it has given the interview preparation questions here as well. Like, can you walk me through your experience integrating multiple LLM providers like OpenAI, Claude, and Gemini into a single product, and how you decide which model to use for different feature? And these are some of the like questions which it generated from the job description itself. So I have given here 5 questions, but you can give it much more than that here. So let me tell you 3 things that surprised me most. Like when I was building this one, the structured extraction is everything. The proposal quality is directly proportional to how accurately the extraction tape parses the job. So if you get a bad JSON right out of this extraction, wrong skills, misidentified deliverables, everything downstream suffers. So I spent probably 40% of my iteration time on the extraction prompts alone. I have to write the correct prompt. And the two, I'll say the tone is massively underrated. Anyone is not giving that, not using that. I used to think a good proposal was a like good proposal and you have to write everything very carefully, but then I tested the same content in a confident tone versus a collaborative tone. It's completely different responses from different type of clients. Startup founders respond to confidence actually, enterprise teams respond to a collaboration framing. Now I look at the client's own job post language first. Are they using we a lot? That means they are very collaborative. And are they listing exact technical specification? Then technical, so match their energy. And the third thing I'll say, The red flag detector is the most valuable feature nobody talks about. Time is your most constrained resource as a freelancer, so avoiding bad clients is more valuable than winning more clients. The agent's red flag detector has stopped me from writing proposals for jobs I would have regretted taking, like that one, which I showed currently. So that's the ROI you can't easily measure, you definitely feel. So this is part 1. The series is going to go much deeper. In the part 2 we are going to add a job scraper agent that actively monitors your Upwork for jobs matching your profile. So instead of browsing the jobs manually, the agent brings the jobs to you. And in the part 3 we are going to simulate a real Upwork AI engineering job, the kind where clients are paying $5k to $20k for a working system, and build the actual deliverable end to end live here itself. And in the part 4, multi-client pipeline, how to manage and customize the profile, and proposals across different types of freelancing personas like data engineer, AI agent builder, ML platform engineer. So like the goal of this series is not just to build tools, it's to show you how the real production AI systems get built with the real issues and real problems and real corporate world, by like actually building them for real problems. So if you build this or anything based on it, I want to see it for sure, and drop it in the comment section. Tell me what you added, what you changed, and what didn't work for you. And if you are using this for your own Upwork bidding for any kind of profession, then I want to know what results you are seeing. Real data from the community is going to make part 2 feel very better, and the full code is linked in the description. Star it if it's useful and it helps more people find it. So subscribe if you want to follow along as this series goes much deeper, and I post the builds, not the tutorials, like real problems, real code, real system. So I'll see you in part 2. Thank you, bye bye, and subscribe to my channel for more such content. Thank you.